International Union of Pure and Applied Chemistry. Is an international scientific organization, not affiliated with any government. The UPAC was formed by scientists and academics who recognize the that all persons could name as would like the compound, but that means that no one will ever understand, and a defined rules make it easy to understand for everybody. It is only in carbon and hydrogen. Exist three main types of hydrocarbons: alkanes, alkenes, and alkynes. The most common hydrocarbons are methane, ethane, pentane, and butane.
In which the covalent bond is very strong. We have single carbons between those carbons, and the general formula is CnH2n plus 2. All of them end in ane, and we add a prefix depending on the number of carbons: meth for 1 carbon, eth for 2 carbons, prop for 3 carbons, but for 4 carbons, and pent for 5, x for 6, and so on. When a hydrocarbon has 4 or more carbons, we may rearrange them, forming alkyl groups. This is the methyl group, this is the ethyl group, this is the propyl group, this is the isopropyl group, and we also have the butyl group, the isobutyl, the terbutyl, the secbutyl, and so on. Now, we are going to see how to name an alkene. First, we have to identify the parent chain. In this case, is this one. And then we are going to see when we are going to start numbering them by the place nearer to the first alkyl group. In this case, this is the alkyl group, and the place which is nearer is this one. This will be the 1, 2, 3, and 4th place. The parent chain is the chain that contains most of the carbons. In this case, it will be 4 carbons. So the name is butane. And we mention the place, the location of the alkyl group. In this case, it will be 2 methyl, because it is that alkyl group, butane. Now, we're going to see how to draw an alkene. First, we identify how many carbons do we have. In this case, 4. And we have methyl group, which is this one. And we have them in the place 2 and 3. This is our parent chain, and we are going to add them. And now we fill with hydrogens. And then we have drawn our 2,3-dimethyl butane.
Organic compound that contains double bond between carbon and carbon. This is an example of alkenes, and this is the general formula. Then, how to name alkenes? First, identify the main chain. Then, number each carbon. 1, 2, 3, 4, 5. Then, identify the double bond, and this is a pen when exists 2 double bonds is the end. because it's an alkene is pentadiene. Then number 1 and 4 contain double bond 1,4 pentadiene. And how to go? First, identify what are the compounds 1,3 hexadiene. Then count and draw the number of carbons 1, 2, 3, 4, 5, 6, and then identify where are the double bonds 1 and 3. Then draw the hydrogens. Double bond, that means that exists 2 hydrogens. Double bond and 1 bond means that exists 1 hydrogen. 1 bond and double bond, that means that exists 1 hydrogen. And double bond and 1 bond is 1 hydrogen. 1 bond and 1 bond means that exists 2 hydrogens, and 1 bond means that exists 3 hydrogens. And this is a 1,3 hexadiene.
The alkynes form part of hydrocarbons family. This is an example, and this is the general formula. You can see? Well, how to name an alkyne? You can see this parent change. Also, for you can begin to count the parent chains 1, 2, 3, 4, 5, 6, and 7. Also, you can write and you can identify the ethyl group. This one. You draw the number 6 and this methyl. And you can locate it. The alkyne is in the number 2. 2 ethane because R7, and the N is in this one, and this is the name of this bond. Also, how you can draw this one. First one, you can observe this part is begin with X. This can say that you can draw 6 C's and the third is the triple bond, and you fall with H. And this how you can draw this 3 hexane.
Carbon is the aromatics. The aromatics, specifically the benzene, is a ring consisting of about 6 carbons attached to each other, and the carbons has single and double bonds. The double bonds comes in pairs. First a double bond, then a single bond, double bond, etc. The aromatic compounds of benzene receive its name because they give the smell to everything, such as fruits. And how to name benzene? First of all, the benzene has 6 carbons, so it always would be an hexane. But we don't write hexane because it's a benzene. Instead, we just will add benzene. Then we have to look for the alkyl groups. In this case, we have CH3, that is a metal group, and ethyl CH2CH3. However, we have to name it in alphabetical order. In this case, ethyl group will come first. Then, to name a benzene, we will start from the ethyl group. So this will be our number 1. Number 1, ethyl. Then we have to look for the metal group. There are 2 metal groups in position 2, 3, position 3, 4, 5, 6, 3, and 6. Then we have to put 3, 6, then dimethyl because they are 2, and benzene. And how to draw benzene? To draw benzene, we have to look for the shape. Benzene, as we say in this case, is the ring consists about 6 carbons. It's not necessary to draw the carbons. Then it says in position 1 and 4, you have to put 1 methyl. In this case, this would be our position 1, CH3. And position 4, 2, 3, 4, CH2. And this is how to draw a benzene. Don't forget to add the circle.
Are very important because with this you can produce other things like bags or plastic bottles or some products that are made by plastic. But for obtaining this type of hydrocarbons, it's very hard. Also, it's very expensive because use machines very big. Also, the hydrocarbons are don't can obtain for
In our daily life are made of hydrocarbons, and hydrocarbons are made of carbon, which is the main component, the main element of organic compounds. This is our life. So we have many benefits from the use of hydrocarbons. We got tablespoons, we got tires, we also got anything made of plastic, which in nowadays is like so many things. So the benefits of hydrocarbons are really very big for us and for everyone, and we must start understanding its composition because it comes from petroleum, an element and compound which will not be here always. And also it is very interesting how hydrocarbons are made because they are like long chains of carbons like no other element has, like no other element can. So it is really interesting, it is important to know, and also it is our world, so we should know about them.
Compounds are so important in our daily life because they form large chains to constitute many products as petroleum, plastics, carbohydrates, fruits, etc. Also for the catenation, that is a characteristic of the carbon compounds, the chains can be attached to another compound as hydroxide to form alcohols and other things. They are so important in our life because carbon compounds constitute the organic life.
Very important because it shows how they are and how to name them, which is very useful for us, as this helps the production of many materials like fossil fuels, like hydrocarbons, and exist many rules to name them. Usually, it helps in many things like the production of fossil fuels or derivatives like plastic. and uniform rules are necessary like the UPAC Accords.